Okay, good morning. What we're going to talk about today are frequency distributions. Some textbooks call them histograms. It depends a little bit on what textbook you're using. I teach out of several, so I'm just interchanging the vocabulary for us. And really with frequency distributions, I'd say there's two general types. The first type is where you have a sort of, oh, whoa, that word is prescribed interval lengths. And the second type is where you have to you must create the interval lengths. Of course, the prescribed one is easier than the ones where you have to create them yourself. I'm going to go through two examples in mega detail for outlining. That's not how you spell outlining. For outlining the two above types. So what I want to do next is I'm going to change the page and do an example on a grade scale. Okay, so this next page that we're going to do is where we're going to do a prescribed interval histogram. Okay, so the raw data are exam scores, and these are actual scores that came from one of my previous classes in statistics. Okay, there's 15 scores, and they are listed as 95, 92, 61, 43, and 87. The next 5 are 80, 77, 89, 75, and 90. And then we have 61, 83, 78, 65, and 21. So these are my scores. Notice there are 15 scores here, and what we're going to do is we're going to build our frequency distribution. So what we do is we're going to talk about it from the score, the value, and what we call the frequency, and it is marked as a capital F, so that means something in math when you see that. Okay, did I say capital F? I meant cursive F, and that cursive F represents the frequency. And we know that the way we label scores is that we have a score of A, or a score of B, or a score of C, or a score of D, or a score of F. And the value of that, right, the value is 100 to 90, or 90 to 100, and then we have 89 to 80, 79 to 70, 69 to 60, and basically then we have anything below 59. So all what we're going to do is we're going to take the scores from above and place them within their frequency. So how many A's from above do you see? I see 3 A's. How many B's from above? I see 4. How many C's? 3 people earned a C, 3 people earned a D, and 2 people happened to fail that exam. Notice that if I add 3 plus 4 plus 3 plus 3 plus 2, I get overall 15. What's key to notice is that this is the prescribed intervals. I didn't make those up. Everyone knows that an A is 100 to 90, 89 to 80, all of that. So those are the prescribed intervals. And we just labeled the frequency within those intervals. And we can then create all kinds of information from this. We could just graph this, right? We could say how many people, right? You could do just a plain old bar graph. And in this bar graph, we have how many people got A's, how many people got B's, how many people got C's, how many people got D's, and how many people got F's. And on here, we could, if we have 1, 2, 3, 4, 5, let's say that's 5. Well, for A's, we have up to 3. For B's, we have 4. For C's, we have 3. And for D's, we have, again, 3 of those. And then for F, we have 2. Right? So that's just this is then a bar graph. And what's kind of important to notice about this bar graph is that it definitely makes it look qualitative, right? So we can see the quality, right? The most people made B's in the class, which was good. I was really happy with the results of that test. And if we go up here, we could do a dot plot, right? This is the bar graph down here, and up here is the dot plot. And the dot plot basically just has as the axis here what the scores are. And so it's very boring. There's a 21, there's a dot. Then there's a 43, and there's a dot. And there's a 61, and there's a dot. If there were any repeating scores, which I don't think there are in the data, no repeating scores. So each score dot is just going to have one dot with it. Versus if we had repeating scores, we might see a couple 21s or a couple 43s. So that's a prescribed histogram with a frequency. What we need to do now is actually talk about a relative frequency. But I think we'll do that later. That is just sort of a prescribed interval histogram and what it looks like. The next thing we need to talk about is when we have to create our own intervals. So creating our own intervals for a histogram. I'm going to do a much more complicated example for this because typically these are done and it is a kind of hard thing to do. So my example that I'm going to talk about is the amount of weight loss for patients at a bariatric clinic. Of course, bariatric meaning sort of dealing with your weight. So we have, let's say we have 72 clients. So yes, all in all, I'm going to list 72 data points. You don't need to copy it down, but I just want to show you what it can look like, right? So I have 9 different columns. I have a 10, a 41. These are actually the raw data. Okay, so I'm listing the raw data here. My screen won't let me type here. 52, 26, 28, 21, 16, 18. Okay, then my next row of data is 13, 35, 31, 46, 43, 25, 26, and 16. Remember that these numbers are representing how much weight a patient lost. The next row or column is 22, 24, 17, 30, 37, 34, 7, and 57. Next column starts at 26, 23, 20, 19, 15, 10, 12, and 32. Then I have 16, 27, 33, 22, 20, 23, 28, and 34. Then I have 23, 16, 18, 13, 11, 29, 20, 28, 35. I know it's a lot of data, but you sort of need a lot of data to make the example a good one. And then 53, 68, 14, 9, 18, 16, and 19. And then the last column is 17, 48, 24, 21, 15, 17, 14, and 26. Okay, so there's our raw data set. You can see that there's 72 clients' numbers, and that some patients lost a lot, like 60 pounds, and some patients did not lose as much, like someone lost maybe 9 pounds in this clinic. So what we need to do is, the problem is we don't know how to break it up. So if we want to create a frequency distribution using 10 intervals. Okay, I want to break it up into 10 intervals, maybe because I think that will make my graph look better. Maybe that will be the way my boss wants me to represent it. Whatever it may be, I'm going to use 10 intervals. So here's something new. How do you determine the interval length? Right? Because you know you need 10 intervals. You know the data ranges from, it looks like the lowest point in the data is 9, and the highest point in the data is probably the 60. Okay, so you need to break that data from 9 to 60 into 10 intervals. The way you do that is the length happens to equal the largest value minus the smallest value, and then we divide that by the number of intervals. So for us, we would then, I need my page to move down, so hang on just a second. For our examples, it turns out that 9 is not the smallest and 7 is the smallest. So we would have our computation look like length equals the largest value is 60, the smallest value is 7, and we're going to divide that by 10. Okay, when we do that, we know that 60 minus 7 is 53. We're going to divide that by 10, and it tells me that I get 5.3. How do you make an interval 5.3? What you do is you round to the place value of the data. So since my data is in whole numbers, no decimals, I am going to say my interval length should equal 5 big. Okay, so once I know my interval length is 5 big, I can construct my frequency distribution and then again my histogram. So what I'm going to do is I'm going to make a big chart where these are my score intervals. Those are my score intervals. I then have my frequency. I'm then going to introduce a new category called the relative frequency. And then there's also something called the cumulative frequency. And I did not do this on the last example, but I could have done this, okay? So my score intervals, this is where things get a little tricky, okay? My score intervals are going to run from 56 to 60, 51 through 55, 46 through 50, 41 through 45, 36 to 40, 31 to 35, 26 to 30, 21 to 25, 16 to 20, 11 to 15, and 6 to 10. And what you should notice about these intervals is that that is length of 5 because we count 50, 56, 57, 58, 59, and 60, and there are 5 things inside of that. So it may look only 4 big, but it is inclusive of 56. So that if you go back to the raw data, the frequency, there's 2 in that category, 2 in that category, 2 in that category, 3 in that category, 2 in that category. There happens to be 7 here, so there seems to be a lot of people there. There's 12 people who lost between 26 and 30, 13 people who lost between 21 and 25, 17 people who lost between 16 and 20, 8 people, and then 5 people. So those are the frequencies, how many data points show up in each of those categories. The relative frequency happens to be equal to sort of a formula. It's the frequency over the total. So we know that the relative frequency here is 2 out of 72. 2 out of 72, and so forth until we come down here and we have 5 out of 72. And we usually use those in decimals, so this is 0.027. 0.027. You could do this for your whole chart, right? The last one being 0.0694 bar. Verify those calculations. Again, you could do them for all of them here. Okay, I will go ahead and show you those in decimal now. This is 0.027. The 3 out of 71 is 0.0416. Another 2 is 0.027. 7 is, I think it's actually, there's 6 of them. Sorry. If you go back, there's 6 of them there. And that is 0.083. Then we have 0.16. Then we have 0.1. This is a decimal, 0.1806. We have 0.2361. We expect that one to be the biggest because it has the most in the category. And 8 is 0.1 bar. Okay, so we have all of those. The cumulative frequency just counts down. We started with 72 data points, and we take 2 of them away, we end up with 70 left. We take 2 away, we end up with 68. Take 2 away, we get 66. Take it away, 63, 61, 55, 43, 30. Then you're going to take away those 17 there, and you're left with 13. You're going to take away those 8, and you're left with 5. And when you take away this final 5, you'll be left with 0. So it's just a way to sort of count down the data points from the total all the way through the data. Okay, so once you have that, the next thing we're going to do is we're going to create our histogram. And I think I'm going to change the page to do that, so you'll want to mark your notes to make sure that you don't lose any of the information. And so if I just make a typical histogram, right, on the bottom here, or sorry, on the side, I am going to have the number of observations. And here I will have the intervals. Again, this is the x-axis, this is the y-axis, so you must count in ascending order, so that this is 0, 5, we'll go to 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. And all what I'm doing here in this histogram is counting the number of observations. And we know that the biggest number of observations, this, of course, the number of observations equals the frequency. So we know that it ranges from, in each of the categories from kind of our previous chart, we know it ranges from 2, so we're going to count here to 2 up to 17. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So up here is 17, and it just counts by ones. Okay. Therefore, in between 0 and 5, there were no observations, but between 5 and 10, or down there at 6 and 10. So we'll start the next one right here at 6. From 6 to 10, this is 5 here. we're at 5. And I'm just going to put a 5 here so we know what category I'm at. And then the next one went to 8. And then we had one at 17, so kind of the biggest category. And what you should notice is that our intervals, this interval is 6 to 10. This interval is from our chart 11 to 15. And I'm not being very particular about how it marks on the axis, but I could be. If I was using a computer program, it would be very exact of where the line begins and ends. From 21 to 25 is 13. And then we have 12, so just one less than that. Then a 6. A 2. Not very many there in those categories. A 3. A 2. And a 2. And a 2. Right, so from this data you can see that a lot of people lost weight inside here, whereas here, not so much. That is a frequency distribution where you make the intervals. Of course, there's a formula and weird stuff happens. For example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 intervals. So note there are 11 intervals because of the rounding that we had to do in our calculation of the 5.3, rounding to 5 in our previous pages. So that is a overall histogram with a frequency distribution. What I want to do now is just wrap it up by talking about general shapes of histograms. And general shapes of histograms, you can have one that looks like this. You may have one in general where you looks like that. You may have one that looks like this, or you can have one that looks like this. Sometimes they look like that. All of those are different. I really should not have made this one and this one look alike. So just a minute here, and I will get my eraser out and fix this because that's real bad. Okay, so I'm going to go back to my pen here, and I'm going to go to full screen. And this one, I should have made it so that the tail is here, and then it comes off. So there's like a tail. These are called the tails, and this is a tail. Okay. This kind of shape, this first one, number 1 here, is what we call skew right. It is opposite of what you think. It's because the tail is on the right. This is skew left, again because the tail is on the left. This is symmetric, which means no skew. There isn't a tail. The tails are the same on either side. This sometimes we call bimodal, where there's 2 humps in it. Notice that the tails again have no skew. All right, so those are the general shapes of histograms. If you go back to our previous histogram, you can see that if I draw sort of a line over it here, it ends up being skew. What would you put in there? I would say it's skew right. Meaning most of the people lost smaller weight amounts than larger weight amounts, if we tie it back to the example we were talking about. That's all on this example. I will include another lecture on some other descriptive statistics.